Water makes up about 85 to 90% of the content of Coca-Cola, so its quality is paramount. The water purification process is one of the most sophisticated steps to ensure consistency across all production facilities. Multi-stage filtration. The filtration process often involves multiple steps to ensure that the water is free from any physical, chemical, or biological contaminants. After initial coarse filtration, which removes larger particles like sediment or rust, the water passes through activated carbon filters. These filters remove chlorine, organic contaminants, and any impurities that could alter the taste. In some regions, reverse osmosis filtration is employed to remove dissolved salts and other small molecules, creating ultra-pure water. Deionization. In certain regions where water hardness is an issue, ion exchange resins are used to deionize the water, removing calcium, magnesium, and other minerals that may affect the beverage's taste or cause scaling in equipment. This is followed by a remineralization stage, where essential minerals may be added back into the water to match the desired taste profile. UV sterilization and ozone treatment. In the final stage of water purification, UV light or ozone treatment is applied to destroy any remaining bacteria, viruses, or microorganisms. This is a chemical-free method to ensure biological safety, as neither UV nor ozone leaves residues in the water. The use of ozone also improves the taste and odor of the water. The syrup preparation is one of the most critical steps in Coca-Cola's production. It involves precision mixing of sugar, or high-fructose corn syrup, water, and the secret flavor concentrate. Raw sugar processing. When regular sugar is used, it is typically delivered to the factory in granulated form and stored in large silos. The sugar is dissolved in hot water at controlled temperatures to create a concentrated syrup. The temperature and mixing speed are carefully controlled to ensure that the sugar is completely dissolved and does not crystallize. To ensure uniformity, the syrup may pass through a heat exchanger that keeps the temperature stable. Use of high-fructose corn syrup. In countries like the United States, Coca-Cola often uses high-fructose corn syrup instead of sugar. High-fructose corn syrup is delivered to the factory in liquid form and is easier to handle. The use of high-fructose corn syrup reduces the energy required for dissolving and mixing, as it is already in a ready-to-use syrup form. High-fructose corn syrup also has a longer shelf life and lower production costs compared to sucrose. Addition of the 7X flavor concentrate. The Coca-Cola syrup formula includes a proprietary flavor concentrate known as Merchandise 7X, a mixture of natural flavors and oils that is a closely guarded secret. The concentrate is added in small, precisely measured amounts. This concentrate includes key flavors like vanilla, cinnamon, and citrus oils. The balance between these flavors gives Coca-Cola its unique taste, making it instantly recognizable. Phosphoric acid and caffeine. Phosphoric acid is added not only for its tangy taste but also as a preservative. The acidity of Coca-Cola, around pH 2.5, plays an important role in preventing microbial growth, extending shelf life, and contributing to the flavor. Caffeine is also added in measured amounts, contributing to both the taste and the mild stimulating effect associated with Coca-Cola. The caffeine content varies depending on the product, like Diet Coke versus regular Coke. Carbonation is essential to Coca-Cola's identity as a refreshing beverage. The carbonation process involves precise control over temperature and pressure. Carbon dioxide storage and handling. Carbon dioxide is stored in liquid form in large insulated tanks at the factory. Carbon dioxide is a byproduct of many industrial processes, and food-grade carbon dioxide is purified for use in soft drinks. The tanks are connected to high-pressure systems that allow controlled release of carbon dioxide during the carbonation process. Dissolution of carbon dioxide. Carbonation occurs by dissolving carbon dioxide gas into the liquid syrup under high pressure, typically between 2 and 4 volumes of carbon dioxide per volume of liquid. The temperature of the liquid is kept very low, near freezing, because carbon dioxide dissolves more efficiently at lower temperatures. At this stage, precise sensors and control systems monitor the amount of carbon dioxide being injected, ensuring consistent levels across all batches. Carbonation optimization. Factories use state-of-the-art technologies such as automated inline carbonators, which precisely control the levels of carbonation. The inline carbonator injects carbon dioxide just before the beverage enters the filler, minimizing carbon dioxide loss and ensuring that the product remains fizzy when consumed. Too little carbonation would result in a flat-tasting drink, while too much could lead to excessive foaming, or even cause After carbonation, the syrup and carbonated water are mixed together in specific proportions. Blending process. Coca-Cola uses automated blending systems where syrup and carbonated water are combined in precise ratios, like 1 part syrup to 5 parts water. These systems use flow meters and sensors to maintain exact proportions, ensuring the product's sweetness and flavor intensity are consistent. Homogenization. Homogenization ensures that all ingredients are evenly distributed within the final product. This process breaks down any particles that may have formed during the mixing process and prevents separation of ingredients over time. This step ensures that the drink has a smooth and uniform texture. The packaging stage is one of the most automated in the factory. It ensures that Coca-Cola is safely and hygienically sealed in bottles and cans. Sterilization of packaging materials. Both bottles and cans are thoroughly sterilized before filling to prevent contamination. Glass bottles are washed with hot water or steam, while plastic bottles may be treated with a food-grade disinfectant. Cans are typically rinsed with sterilized water. The washing process is closely monitored to ensure that no residual chemicals or contaminants remain inside the containers. Filling process. Automated filling machines are capable of filling thousands of bottles or cans per minute. The machines are designed to maintain precision and avoid spillage or loss of carbonation. The beverage is filled under pressure to keep the CO2 dissolved, and advanced filling valves control the exact amount of liquid that goes into each container. Capping and sealing. Once filled, bottles are capped using high-speed capping machines that ensure a tight seal. Cans are sealed with lids using crimping machines, which compress the lid onto the can to create an airtight seal. This prevents any gas from escaping, ensuring that the drink remains fizzy and fresh. Quality control is implemented at every stage of Coca-Cola's production, from the raw materials to the finished product. Chemical and physical testing. Regular chemical analyses are performed on both the water and the final product to check for pH, sugar concentration, CO2 levels, and other critical parameters. Physical properties such as bottle weight, cap tightness, and fill level are also monitored to ensure they meet the company's strict specifications. Microbial testing. Samples of the beverage are regularly tested for microbial contamination. Coca-Cola adheres to strict food safety regulations to ensure that no harmful bacteria, yeasts, or molds are present in the product. Advanced testing technologies such as polymerase chain reaction, PCR assays, are used to detect even the smallest amounts of contamination. Sensory testing. Sensory testing involves trained tasters who sample batches of Coca-Cola to ensure that the taste, smell, and mouthfeel are consistent with the brand's standards. These sensory experts check for the appropriate sweetness, carbonation levels, and the balance of flavors to ensure the Coca-Cola experience is uniform. Once the quality control stage is passed, Coca-Cola products are ready for packaging and shipment. Automated packaging lines. Packaging machines are programmed to pack Coca-Cola into various configurations, from individual bottles to cases and pallets. Robots are often used to stack cases onto pallets, ensuring that the packaging process is both efficient and precise. Cold chain logistics. Coca-Cola relies on an extensive distribution network to deliver its products worldwide. In some regions, Coca-Cola products may be transported in refrigerated trucks to maintain quality, especially in warmer climates. Maintaining a cold chain helps preserve carbonation levels and prevents product spoilage. Sustainability initiatives. Coca-Cola has implemented various sustainability initiatives to reduce the environmental impact of its packaging. These include using recycled PET, or PET plastic in bottles, reducing the amount of plastic in packaging, and encouraging the use of returnable glass bottles in some markets. Coca-Cola also invests in energy-efficient technologies and renewable energy sources for its factories.